Welcome to Pre-Calculus Notes for Essential Skill B3 Part 1, Sketching Polynomial Graphs. We have two major tasks in this set of notes. First is sketching polynomials given the polynomial. The second is to determine the polynomial given the sketch. First, sketching. This is a big task, and so we have a plan. We're going to figure out where the outputs are zero, so in other words, the zeros of the polynomial. That means we'll be dealing with polynomials that are in factored form. We can read the zeros right off of it. For example, if we have f of x equals x plus 2 times x minus 3 times x minus 1, the zeros we can read right off the list. We'll plot those on a number line. And then we'll begin testing the intervals to see if they're positive or negative. In other words, are all the y values between x equals negative 2 and x equals 1 positive, or are they negative? To do that, we'll make a table. We'll write the factors of the function, and then our result column is going to be, is the product positive or negative? The first number I'm going to test is going to be in the leftmost region, negative 3. Negative 3 plus 2 is a negative number. Since we're finding the product of these three factors when plugging in negative 3, all we care about is it positive or negative? That'll be enough to tell us whether the product is positive or negative. We'll continue. Negative 3 minus 3 is negative 6. That's a negative number. Negative 3 minus 1 is negative 4. That's a negative number. So a negative number times a negative number times a negative number is a negative number. We mark that on the number line. In the next interval, we'll test 0. 0 plus 2 is positive. 0 minus 3 is negative. 0 minus 1 is negative. The product is a negative times a negative, which is positive. So this interval between x equals negative 2 and x equals 1 is going to be entirely composed of positive output values. Now that we've used all the products to mark the number line, we have enough information to do our sketch. I'm going to start by marking the x-axis with all the critical points, done roughly to scale. Our critical points are the zeros of the function, so that means that they are x-intercepts. Our zeros are going to partition the graph into positive and negative zones. So I'm going to mark these zone boundaries and then look back at the number line. Our zones were negative y values, positive y values, negative y values, and positive y values. I'm going to transfer these markings to the graph. With our zeros marked, as well as our negative intervals and our positive intervals, we have enough to draw a rough sketch. Negative y values, positive y values, negative y values, positive y values. Notice this is only a rough sketch. What makes it rough is that we don't really care about the y scale. We only care about positive, negative, or 0. If you were to graph this function on a calculator, you'd see that this is not really to scale, but it's pretty close. It has enough important information. In this example, the zeros take a little bit more thought. X squared generates zeros of 0. That's because this is like saying x minus 0 squared. To find the 0 generated by 1 minus x, well, what makes this 0? X is going to be 1. And then x plus 1 and x plus 3 are a bit more traditional. Some of these are squared. We'll see how that affects things a little later. Now we make our number line map. We've divided the number line into 1, 2, 3, 4, 5 regions, and so we're going to have 5 rows on this table. Here I've given you the table. I'm not normally going to give you the table. Normally you'll need to build it yourself. I want to point out some things. The exponents come with each factor. 1 minus x still transfers as 1 minus x. And we'll still evaluate by plugging in the x's. We'll pick -4, -2. Here we're between -1 and 0, so we'll need -1/2, +1/2, and then 2. X squared, always positive. So anything squared generates a positive result. We can fill all of those in. Same thing with x plus 1 squared. That will generate a positive number. Now we can plug in 1 minus -4 is a positive number. -4 plus 3 is a negative number. So our product, which is f of x, remember that f of x is the product of all these factors, it is negative. When x equals -2, 1 minus -2 is positive. -2 plus 3 is positive. This will be a positive. 1 minus -1/2, still positive. -1/2 plus 3, still positive. We have a positive interval. Notice that fractions don't really complicate things when all we're doing is looking at positive or negative. 1 minus 1/2, clearly positive. 1/2 plus 3, it's something positive. 1 minus 2 is negative. 2 plus 3 is still positive, so we have a negative region at the end. Remember, we plot our critical points first, roughly to scale on the x-axis. These are the zeros of the function, so they will be x-intercepts. Don't forget the 0 at 0. It's not necessary to draw these dividers, but I find that it's helpful when learning this technique. And now we mark our intervals. We had a negative interval, positive interval, a positive interval, a positive interval, and finally a negative interval. We read this from the number line chart. Now we can draw the graph. Negative to positive. We still have to intersect this 0, but we stay positive. And we have to intersect this 0, but we have positive on this side too. Now we can pass through into the negative interval. One thing I want to draw your attention to is this bouncing behavior near x equals -1 and x equals 0. If we look back at the original function, the factors associated with 0 and the -1 were both squared terms. What's going to happen visually is that this is going to look like the bounce of a parabola. We'll explore that in the next section. This would be a good time to look at the problem set and try problem number 1, just to see if you can do this simple example. We'll look at what happens when it gets more complicated in the next video.